they're telling you that this is in point-slope form. Does it look like it's in point-slope form to you? Well, point-slope form, almost. It is. It just, yeah, well.
Oh, in point-slope form? Yeah.
Yeah, it's almost in slope-intercept form because y is by itself. You're right. If we wanted to do the b part, put it in slope-intercept form, we would just have to distribute here. This one is in point-slope form because what do you think the y1 must have been? Well, see, let's look at the right side. We got the slope. We got the x minus a number that we were expecting. Why isn't there a number subtracted from y? It's 0, right? It's 0. Is the lazy math guy going to write that 0 down? No. That's why he just put y. So if they tell you something's in point-slope form, or if everything else is and one looks a little different, it could be that you could just add that 0 in. Because one of the things you're supposed to do here, is graph the point and the slope. Graph this equation from the point and the slope given in the equation. And you might think there's not a point in there, but there really is. If I'm looking for x1, y1, which is what we see in the formula up here, what would my x1 be? You need to go to the bathroom? Oh. What would be the point that I would pick out of here? If I add that 0 in, I can pick my point out easier. So anytime you see that a piece is missing, it's probably just because there was a 0 there and they didn't want to write it in because y minus 0 is equal to y, such as in this case. Wouldn't my x1 be this 12 here? Okay? And what would my y1 be now that I've added that 0 in? It's the 0 that they didn't write in there. So a lot of times if stuff's missing, you might try filling in with zeros, you know. Now, okay. Yeah, he was copying you. Okay. So if I want to graph this, I honestly am going to have to make my hash marks a little closer together. 1, 2, let me make bigger ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can barely fit it on there. So there would be my point when I graphed it at 12, 0. And then my slope was a positive 1/3, wasn't it? So I can count, this is going to be, okay, well this is a good example. I can't go up 1 to the right 3 because I'm going to run off the iPad, right? So what can I do? If you're at the edge of your graph, if the slope is 1/3, can I write a number equal to 1/3 that has negatives in it? You could do, okay, what if I did this? What's a -1 divided by a -3? It's a positive 1/3. So since those numbers are equal, I can graph that as my slope. As long as the numbers are equal that you graph, you can do it. So I'm going to pick this because this tells me I can go down 1 and to the left 3. Down 1 and to the left 3. I could keep putting points on my graph if I wanted to that way. And that's how I'm going to get my graph when I run off my graph paper, or in this case I'm just out of room on my iPad. I can't go to the right. So this would still allow me to graph it on the space that I have. And that's what you do when you get on the edge of your graph and you're supposed to go out to the left or right or something and you don't have any space. You just think this is an equivalent fraction, isn't it? So our slope is still 1/3. I'm just going to write it as -1 over -3. So this is a good time to talk about that even. Okay, so that was part A, was graph it and show the point and the slope from the graph. And the point was kind of hidden there because it was actually y minus 0 instead of y. So part B was supposed to be to write this in slope-intercept form. And slope-intercept form is y equal mx plus b. It's the one that you're probably more familiar with that we covered in 3.2. And I know that I put something in y-intercept form if the y is by itself and I've totally simplified it. So what I can do is just take equations and solve for y, and they will automatically be in the form I need. Hi, can you kind of cut that way? My head was in the way. So if I've got to solve for y, isn't y already by itself? So a lot of the work's done on this one for me. It'll go faster. So I just have to distribute over here. 1/3 times x is 1/3 x. 1/3 times -12. A positive times a negative is a negative, right? And 1/3 times 12. Isn't multiplying 12 by 1/3 the same as dividing it by 3? What's 12 divided by 3? 4. That's the slope-intercept form right there. We didn't have to do as much work on this one as... Part C tells us they want us to put it in this AX plus BY form, which used to be called standard form in our old book, and now he's calling standard form something else. So what I need to do here is get the X's and Y's on one side. I'm going to start with this form right here. I could go all the way back to the beginning, but haven't you already at least distributed here, so you're kind of already on your way to working this one?
Sure.
I need my A's and my B's to be whole numbers. Those two need to be whole numbers. And the A needs to be positive. Is the A positive where it is right now? Leave it where it is so it's positive. So what that means is, let me move the Y to the other side. I can move things from side to side by subtracting and adding, can't I? I can move that over there just like that. What I just want to say, oh, that canceled out. Yay, I have this left. Is that okay to leave it like that? Nothing equals something over there, okay? So we can't do that. We have to say Y minus Y is 0. Okay, so if you notice the way this form runs, the X and the Y are on one side, and then your constant, your plain old numbers on the other. So why don't we move that 4 to the other side? So now I have 4 is 1/3 X minus Y. A lot of what we're doing here is just polite math communication. When you see a problem, you usually don't want to see the number on the left-hand side.
So
Right-hand side, you want to, yeah, we're going to move it over there, but we're not done yet. That's more polite, but we don't like looking at fractions, and we're not going to give this to somebody back in a fraction. That's considered not proper etiquette in math. So how could I get rid of that 3 on the bottom of that fraction?
Set everything equal.
Well, we don't set there. You want to do something with the 3.
Divide.
How about multiply? If I multiply, it would get rid of it. It's kind of like it's 1/3 is almost like kind of like dividing by 3, isn't it? What if I multiplied everything in that equation by 3? What would 3 times a third be? 1. So you'd have 1x, which lazy math guy would just write x, right? What's 3 times negative y? Wouldn't it just be minus 3y? And then 3 times 4 is 12, and there you're done. I picked the 3 because I wanted to get rid of the fraction. And so what you do is you look for what's in your fraction, what's in your denominator, your fraction, and you multiply 3 by it. Had it been something, you had 2 different numbers, you would find if you remember, y'all used to call this the least common multiple. You'd find the smallest number that both the numbers will go into.